Okay, is in the middle between two charges of 5 and -2. What's the total force? Alright. So one of the forces will push and the other one will pull. Okay, let's calculate it. So in the middle is your A, and then here there's a +5 microcoulombs, and here is a -2 microcoulombs, and the A is a positive 3.79. So what will happen is it will be pushed to the right from this one, and it'll also be pulled to the right from this one. So the total force will be K. If I call this one Q1, this Q2, and this Q3, it'll be K Q1 Q2 over R squared plus K Q2 Q3 over R squared. Now the K and the R is the same in both, so I might as well just take it out. K over R squared Q1 Q2 plus Q2 Q3. So what's that? 8.99 times 10 to the 9 over 0.125 squared. Q1 is 5 micro. Q2 is 3.79 times 10 to the 15 plus, and then Q2 is 3.79 times 10 to the 15 times Q3, which is 2. 2 times 10 to the minus, oh sorry, that should be -6 there. -15, -15, -6. Alright, so just here these are multiplied, then it's plus, and then these are multiplied. Do you want to bash that into the calculator and see what you get?
The R is 0.250 or
250 is the distance from here to here, I believe. Yeah, see if we get the same answer.
K is a constant.
Hmm?
K is a constant.
Mm-hmm.
Why calculator doesn't have
Correct, nobody does. It's in the formula book.
why calculator doesn't have any constant?
Oh,
Oh.
really? It's not in the calculator, it's K.
Well, it is if you type in 1 over 4 pi epsilon 0.
Oh, I think why I got it
I
right.
don't tell you use the other K.
Yeah.
Ask the Boltzmann's constant, that's totally different.
That's good.
What the heck is that?
What?
So, yeah, that.
Tradition.
Yeah, but it's so black. What is?
Yeah, I was
Picture.
writing in the back. Yeah, no more space.
Yeah, but how can you read that? Like, what's supposed to be a photocopy of?
It's a picture.
Oh, it's a picture.
Yeah.
Huh?
It's a picture.
Oh, I get it.
Even if you don't have the constant in the calculator, is it in the formula book?
Correct, all of that should be.
Okay.
What's wrong?
Question. If you close this switch,
Yeah?
will the brightness increase or decrease?
Haven't a clue. I'll have to calculate it.
Can you calculate it? How?
Don't they ask you to calculate it?
No. State what happens when the brightness of the lamp when switch A is closed.
It's going to. Is there another resistor that's entered the circuit? Like when you close the switch, what gets included?
Motor.
A motor. Yeah. Okay. So another resistor. Yeah. Brightness would. That's what I'm going to say. It depends how it's connected and how. Did they give you the resistance of the other resistor? Can you pass that up? Let me have a look at what they have. Switch A is closed and a total current of 2 amps now flows through the battery.
Where did we get the answer?
Hold on. Well, you see, I think you might be right, it goes up, but it doesn't matter if you don't know, because the thing they ask you to do before that is to calculate the voltage. Do you know what I'm saying? I don't remember these things because they don't ask these things in the exam. The previous point that they asked you was what is calculate the voltage. Do you get what I'm saying? Like, they ask you to calculate the voltage, and then the next point is what happens to the brightness.
They also calculate the voltage?
They do, it says determine the voltage. And then it says state what happens to the brightness of the lamp. So then the question really just becomes, do you understand that lower power means less bright? Because they've provided the current as well. And so it looks like the current is 4 times bigger. Anyways, I don't think this is a question that's actually testing if you know what happens when switches close in parallel. I think it's only testing that you can understand the meaning of the last result. I understand why you didn't see that, because they don't have it marked correctly. So there's actually, although it's only marked part 1, part 2, there's actually 3 questions here. So it should have been 1, 2, 3. The previous point was determine the voltage. It said determine the voltage across the motor. Yeah, but because these are in parallel, they should be the same voltage, which means it has to be the same as this. So I'm imagining because the current increases, it gets brighter. But you can calculate it and see. Did you get an answer over here?
Yeah, but what is in the third one, Q3 negative 2?
I considered the minus already by how I drew the picture.
Oh.
That I considered the effect already. Yeah. Are we okay with this one?
If both point charges are minus or negative, is it still plus?
No, actually, because like if it was like plus plus plus, something like this, you mean? This is being pushed to the right and this one pushes it to the left. So yeah, you would need a minus sign in here. He asked me why don't I have the minus here in the Q3, because I already considered the minus with how I drew the force, and I understood that these forces combine. So this plus actually represents the minus. I've considered the direction.
Is the answer wrong if we write it in, if we put a negative in front?
Put a minus here?
Yeah.
And what do you put here? On the
Positive.
yeah, a plus and a minus.
Yeah.
You should get a different answer to me, which would make it wrong then, I think. Please note, the purpose, is that the door? Oh, that's good. Please note the purpose of the plus or the minus is only to show direction. You should really think about if you need to include that in your calculation. Bruce! Come on. Okay, that's fine, come on. It's the last week, so I don't care what you do. Last week, isn't it?
Is it?
Yeah.
Yeah.
Right, what's next?
22.
Oh wait, did you get an answer for this yet?
Yeah.
Okay, well while he's typing it in, 22, the first one. Good. Okay. Top of 22, please. What's the answer here? Okay, question mark, whatever it is. Right, top of 22. Sketch a graph of force against extension. Extension in meters. Whoa. Force in newtons. Now come back. Right. For a ductile material such as brass, ductile meaning just a usual flexible material. Let's just check your English here. Does anybody know the opposite of ductile? Huh?
Something like rigid.
It is rigid, yeah, correct, yeah. So, rigid meaning you can't change its shape. Ductile means it's you can change its shape, manipulate it. Yeah. Anyways, what way does the graph look here when you plot force against extension? What type of graph do you get? Huh? Yeah, so linear. Up until you reach a point. Yeah. In fact, I think its exact name is elastic limit, which is the breaking point, yeah. Where's my pen gone? Hello? Pen? Hmm? Yeah, go ahead. It's stuck. When it resumes, I'll continue. But anyway, if you want to draw this in, it's a straight line, and then it reaches a point, and then squiggles off. Depends on which book you're looking in. It's not important for the exam. For the exam, they usually just want they want to see not a straight line. Here we go. Where's my, come on. Oops, upside down. So this point here is the elastic limit. And this part of the graph is the elastic part, and this part is the plastic part. That's 4 marks.
Okay. I just didn't know how to try.
That's all you needed to see?
Yeah.
Okay, that's good. Pretty nice for 4 marks, wouldn't you say? Okay. You have a question, Audrey?
Page
13. Let's have a look. 13. Alright, which one? First, second, third? First one. Oh. Okay. 8 marks. Yeah. Top of page 13. Got it? Yeah. Okay. Physics is your first exam, isn't it? Second exam. What's your first exam?
Chemistry.
On what day?
Tuesday.
Next week. Physics is this Friday?
No. Next Friday.
Chemistry on Tuesday? Nothing on Wednesday? EAP on Wednesday. And Thursday. And then Physics Friday. And what's on Monday? Maths is on Monday.
Friday.
Monday after Physics?
Yeah.
Yeah.
Are you sure?
Yeah, I haven't said nothing else.
Because I was told something opposite. It's important we make sure this is correct. Because I was just talking to the principal this morning, and she told me maths will be like first or second exam after EAP. You're saying it's the last exam. So you're saying the principal's a liar. Who sent you this email? Do you mind double checking it? Because it makes a big difference if the maths exam is the first one or the last one. Oh, I didn't say so. Alright, okay. What date does he have for maths? Or does he have the days, not the dates? Okay, so what did he have for maths? 23rd. What did he have for physics?
20.
This looks like it came from NCUK. No. That's maths, business, maths engineering, maths science is on the 23rd. That's Monday.
Yeah.
But Monday 2 weeks from today.
Yeah.
Okay, and then physics is on the 20th. Friday. Okay, well that's actually what I thought, sorry. What's after your maths exam?
Nothing.
Ice cream.
Ice cream indeed. So, when the principal said it was the first exam, what she actually meant was, it's the last exam. Yeah, they're very different situations. Okay.
There you go.
Are you going to come back?
No.
Oh, seriously, or? But you're going to leave your stuff? We'll see what happens, I suppose. Right. So the maths is 2 weeks away, and the physics is less than that. It's the Friday before the maths. And your first exam is on
Next
Tuesday. That's nearly a week away.
Yeah.
Wow. That's weird. Alright.
Why?
Chemistry, a week before the other subjects. Chemistry is usually like in the middle. It's not like chemistry, no exams, EAP.
No, the chemistry is EAP.
Oh, I see, okay. Still, it's strange, starting with chemistry. How weird.
Oh, it works.
Really? Alphabetical, is it? No, because then business would be first, wouldn't it? Right. Yeah, that's okay. I need to double check, make sure the principal has the right ideas. Okay, let's have a look at the top of page 13 then. A uniform shop sign of mass 8.5, width 0.6. It hangs from a steel bar, which is one. Okay, so everything's in the picture, yeah? Except for the mass is 6.5 and the steel is 1.5. Ah, is that the fella? What's his name? No, you're not Darius. Alright. Okay. So, because it's 1.5 and it's in the middle, I'll just draw a 1.5G here. And then the sign is, what is it, 8.5?
Yeah.
And that I'll put here. And that's 8.5G. You're happy with that, I imagine. And this distance is 0.5 of a meter. This distance is 0.3 of a meter. So this distance here is 0.2 of a meter. Okay, and we have another force here. We also have another force here, which is the reaction at the hinge, and this is the tension. And this theta here, we can work it out. Theta is tan inverse 0.8 over 1. Do you mind getting that for me, please? What's tan inverse 0.8?
38.66.
Okay. Right, so basically the question is figure out everything. So what I'll do is resolve this. That's t sine theta, and this component here is t cos theta. So if I say t sine theta oh, now look, there's two components here. Whoops. I have no idea what that angle is. I have no idea. So I'm just going to call this something like or x and or y. So I have no idea what the angle is. So it's going to be t sine theta plus or y equals 8.5 plus 1, it's 10g. And then I can say t cos theta equals or x. Now let's just look at what we have. So, do we know t? No. Do we know sine theta? Yes. Do we know or y? No. Do we know 10g? Yes. Do we know t? No. Cos? Yes. Or x? No. So there's three things I don't know. T, or x, and or y. So this cannot give me any solutions because I only have two equations with three unknowns. There is one equation I've yet to make, and that's the turn-in one. If I use this as the turning point, then I can say, what's this one? Clockwise plus clockwise equals anti-clockwise. Don't count this one because it passes through the center. So I can say 1.5g times 0.5 plus 8.5g times 0.7 equals 1 times t sine theta. And I'm finished now because I know theta, I know these, so I can easily get t. And then as soon as I have t, I can put it back into here. I know t and cos, so now I can get or x. And then I can put it back into here as well. I know t, I know sine, I know 10g, so then I can get or y. And that answers everything. So this answers part 1. This answers part 2. And then here will get you the answer for part 3. I don't think you need me to work it out. It was just... Well, actually, what did confuse you here? What stumbled you?
I forgot to use the turning.
Yes, that would be useful, wouldn't it? Yeah. So you tried to solve this with two equations, basically. Yeah. Yeah.
If voltage decreases, it will become brighter.
Well, if the power decreases, if the power increases, it becomes brighter. So the voltage perhaps decreases, but I think the current increased a lot.
Yeah.
So how much did the voltage decrease by? It went from what to what?
2 point something.
To
It was 14 point something to 2 point something. 12 point something.
14 to 12.
Yeah.
But I think didn't the current increase by a factor of 8?
You.
So I feel like the power, which is current times voltage,
So the brightness is based on
the power, yeah.
Will you get the answer for this?
No, because I don't have it. Well, I have it, but
Then it's a lot of questions.
at this exam, I definitely can't give you the answers for this one.
So I can ask
Of course you can ask and I can help you with it too.
a lot.
A lot. Okay. Let's have a look.
Is this a forward bias circuit?
It is. Let me draw that. Guys, do you remember we had the circuit for getting the IV characteristic curve? So you start off with a power supply, like this, and then you would have like a switch here. Then you would have something like a variable resistor here, for example, and then you would have like an ammeter here, or something like this. It doesn't have to be exactly like this. And then this would connect up to your resistor, and there'd be a voltmeter here. And then you would draw your graph, and then what is it? V here, isn't it? And I here. And if it's ohmic, it's like this. And then, what was the other ones? the filament bulb increases in resistance when the voltage increases. So I think the filament bulb goes like this. And then do you remember the diode? Do you remember what happens with the diode? I think it starts off low, wasn't it? Or high resistance. It's like this, and then it shoots up like this.
No, it's like
Slowly increasing, and then shoots. And then the same thing happens at the back, but it takes longer. It's flat for much longer, and then you have the runaway. Yeah. So for the diode, the direction matters, because if you reverse the current, it can't really pass through until it breaks the diode. So the way we indicate the direction is we draw the resistor like a little triangle here. So this is how you draw a diode. Now I don't think I showed you that, and the reason I didn't is because in the syllabus it doesn't provide a list of what are the icons you're supposed to know for the circuit, because there's many different things you can have in a circuit. You know, you can have like motors, and you see here that motor is this symbol here for a motor. Now I used to show students this symbol, and I removed it from my slides because I noticed in the last 10 years they've never used that symbol in the exam. Until this year, with the September students, they included this circuit, this symbol here. Now it said in the question that it is a motor, so you'll figure out that the one with the letter M represents motor. But you might not have figured out that this is the diode. So it's worth perhaps writing that down somewhere, that the diode is this symbol. The problem is, if you look at the syllabus, it would say something like, students need to know the symbols that's used in this course. What symbols? You didn't tell me which ones. Okay, so what's your next question then?
How to sketch a graph? What do you mean include a realistic scale on the voltage axis? How do you know what is considered realistic?
That is a very good question. I think I don't know how flexible they want you to be, but let's just put it this way. Where are you going to see diodes? In what type of appliance? You don't know? Let's think about the opposite then. The filament lamp. What type of voltage would that be? Big or small? Filament lamp, like the lamp on the wall.
Okay.
Yeah, like 220.
Okay.
Yeah. A regular resistor could be like 220. The diode is something that you see in like electronics. So what type of voltage is an electronic device? Come on. Like, think about your phone.
I don't know stuff like that.
I would think a reasonable scale would be like 1 volt perhaps, rather than say 100 volts. I don't know.
More of like 1, 2, 3, 4 or 0.1, 0.5, 0.0.
I would just say use millivolts and milliamps, and just mark this off as 1,000 or something. I think they just wanted you to say that the scale is millivolts and milliamps. That it's not like kilovolts or something like this.
And the third question.
Yes. What's the third one? Explain how the diode is able to protect the ammeter. So this is testing if you understand what happens when something's in parallel. Okay, so guys, I'm just going to do an extra question here. So the question was, this was from the September exam. They say, imagine that you have an ammeter And then imagine that you have a diode here. And what's special about diode, if you remember, we talked about this, the resistance, are you sure we drew the graph right? Because as the voltage gets bigger, the resistance decreases. Yeah, it's like this. That's how the graph looks. Yeah. So, anyways, the key thing about this is, if the voltage and the current gets very large, the resistance drops. And you can see that with the graph. The graph looks like this. When it's like this, it means the resistance is actually small. It's nearly zero. Okay. So they wanted to know in the exam, how does this help protect this against large currents? Well, let's just imagine what would happen. Let's say we have I1 here and I2 here, and this is I here. And we'll say that I is very, very big. So this one here has a resistance. The resistance in the ammeter is going to be pretty small, so I'll just write it as a small, or just as an OR. OR1, and the resistance here will be OR2. Which will be bigger, OR1 or OR2? Let's see. Well, it depends what's happening with the current, okay? So if the I is small, then the OR2 is big. And if the I is big, then remember we said the OR2 is small. That when this current gets very large, the resistance here drops. Okay, so let's see what that effect that has. Let's see, we could do Kirchhoff. Yes, Kirchhoff, that's what I said. Right, so if I start here and go around, that would be minus I2 OR2 plus I1 OR1 equals 0. So you can see that I1 OR1 equals I2 OR2. So you can see that I1 over I2 equals OR2 over OR1. I get that right? Yeah. So why the heck does that matter? Well, if the OR2 is small compared to this, it means when you look at this one here, the I1 should have to be small as well. You know, if you have a fraction where the top is smaller than the bottom, smaller, and you have another fraction here and it's the same, then likewise the top has to be smaller than the bottom. You know, you couldn't have something like 2 over 8 equals, if I wrote another number here, 10. This number here, will it be bigger or smaller than 10? It absolutely has to be smaller than 10. Because, you know, this fraction here, the top was smaller than the bottom. So anyways, my point is, you can see that this makes I1 small. And where is I1 going? It's going into the ammeter. So in other words, when the current here becomes very large, most of it will travel up the top and only some of it will go down the bottom. So this is how the diode can protect it. Now that's a very difficult question. You'll really have to think about that. How many marks was it? Only 2 marks. You don't have to write all of this down. I was just trying to explain it to you. You can simply just remember this result. So the result is the diode in parallel will take most of the current when there's a sudden increase in the current. That's how it protects it. So the diode takes most of the current when there is a surge. And you can draw a little picture here. There's the ammeter and there's the diode.
Is it only applicable for parallel?
Yeah, it has to be in parallel.
It's series?
It's series. No, you wouldn't put it in series because then it makes the ammeter useless, because the ammeter can't measure the current anymore, because You're interfering with the circuit that you're probably trying to measure, so you wouldn't put in series. Oh yeah, sorry. Diode takes most of the current when there is a surge. Yeah. Sudden increase, sudden spike. If you want to use full sentences, you can. Yes, when there's a surge in the current. Surge is a word in English that only ever really refers to electricity. So that's why I felt I could stop my sentence, because I had to be referring to the current earlier in the sentence. Next question?
How to draw electric field line between parallel plates?
You know this one.
I know, but like, if the upper plate is higher potential, that means the is going down. The upper part is higher.
Yes.
So it goes down.
Yes. As I promised, when you finish all of these questions, it's better for your health to just be looking at this one. I only gave this to her to keep her quiet, because she has everything here finished, and she was looking for me earlier. My biggest worry is if I do this exam for September, people will think, great, I don't have anything else to do, I've seen the September exam. That's why I have the rule about having the book finished. Now, of course I can do it, but trust me when I say this, really trust me. Doing the questions in this will help you succeed. Because the September students obviously didn't have access to the September exam beforehand. They just had this book, and they did quite well. You know, a few A's and A stars in the group.
Yes. A and B is not much difference. Section A and B.
No, there is a difference, but the difference is so meaningless. Like,
Definitions.
no, because you could have definitions in section A, and you could have graphs in section A. I can't think of any question that is only in B and not in one of the A's. But what's nice about the A's is it's really good for revision, because you're doing lots of small questions. But the section B is just going to be a collection of A's together that might connect. But really, if I think about it, like, for example, the section B mechanics question, it might be like, this might be like part A, and then part B might be a projectiles, but it could have many sub-questions, like, what is the maximum height? What is the range? What is the kinetic energy? And, you know, all this type of stuff. It's good revision to do this instead. Yes, Wei, you have a question? Sketch a graph of kinetic energy against time for the pendulum, is it? Simple harmonic motion. Alright, everybody now, I want to make a graph, and this graph I want time on the x-axis and kinetic energy on the y-axis for a simple harmonic motion. So let's imagine we have a spring, okay, and I pull the spring out and release. What will the graph look like? So this is kinetic energy in joules, and this is time in seconds. Time in seconds. What would the graph look like for the simple harmonic motion? I pull the pendulum out, release, and it starts moving. Yeah, so first the energy increases, reaches a maximum, decreases, and then what happens? Goes what? It doesn't. It's kinetic energy. It can only be positive, you see. This caught a few students out in a lot of students in the September exam did something like this. They were getting confused because kinetic energy is speed. So it goes fast, slow, stop, fast, slow, stop. Its energy looks like this. Now in real life, if it's slowing down, it'll be like this until it stops. In the exam, they asked you to do 2 cycles. Now, hang on, be careful, 2 cycles. Did it say 2 cycles?
One full cycle.
1 full cycle. So this here is the periodic time. Because if you think about the pendulum, if I pull it out, it goes down, slows down, stops, and then heads back up, and then stops on the top. So this one here is when it's halfway in its journey and has stopped on the other side. If this is plus A and this is minus A.
How do I know if it starts at equilibrium?
No, in the marking scheme it doesn't matter, because they said if the student had it the other way, that's fine too. Yeah. Not many students got this right now. They all got confused because they were thinking of the energy graph, or they were thinking of maybe the displacement graph. They just got confused about what was happening. Yeah.
So you took the current.
Go on. Use your words. What are you asking me?
Because like the energy is positive going down.
The energy is always positive because it's kinetic. Even going down, its speed is still, it's still moving.
If they ask
Sorry, just 1 sec there. It's because the formula for kinetic energy is this. It's always a positive number, kinetic energy, because it's a half the mass times the speed squared.
It should have potential energy.
Oh yeah, and they didn't ask us to draw it. And it should have potential energy, yeah.
Why isn't there like space?
Space?
Because it's like why isn't it's moving?
Let me think. Does it make sense? What would potential energy look like? Potential energy would be the opposite, wouldn't it? Now the reason these graphs look so weird is because when we did the graphs, we didn't put time here, we put X here. And this actually changes how the graph looks. The situation is the same, but it just looks quite different if you're looking at the time instead of the displacement. This is part of the reason it looks so weird. I think this is what confused a lot of the September students too. Yeah?
if they ask for total power dissipated, do we just calculate the power?
Yeah, he likes his words, doesn't he? Power dissipated and all this. It's just power.
Page 11.
Page 11.
A1 part
A1 part
2.
2. Explain why an object moving in a circular path at constant tangential speed is said to be accelerating. Classic question. Right, so they want to know why, if something is moving in a circular motion with constant speed, we say it's accelerating, even though the speed is constant. Okay, so acceleration is the change in velocity over the change in time. Yes, and velocity is a vector which equals speed, in this case, and direction. So, although speed is constant, direction is not. So, that means the A is not 0. Because the A is changing velocity, and the velocity is changing because the direction is changing. Even though the speed's not, we still say it's accelerating because this velocity vector is changing, keeps changing, so it's accelerating. It's usually the speed that changes, and we say it accelerates. But if somebody was walking at 1 meter per second and then turned around and was walking at 1 meter per second backwards, we actually say they're accelerating, or at least they accelerated at this point because they changed their velocity, because they changed their direction. So that's the idea here. Good? Bad?
Okay.
It's okay? You don't like it though? It's a trick question. Well, no, it's kind of a trick question.
How to do number 3? B3.
B3. Well, just
If you,
recalculate with different charges.
but if it's negative and then you plus 2.5 and then it becomes positive, it changes direction.
Ah, so then you'll have to do a bit of a recalculation, is it?
But it does change direction.
It might change direction, yeah. This is weird. What? Point A is 2.5 and point B is minus 1.5. Oh, you're right. Yeah, wait. They both become positive now. So the force is opposite direction. Previously it was a positive and negative, so it was
Your
attracted. It's just Coulomb's law, no? K Q1 Q2 over R squared. Yeah?
Is KQ1 Q2 over R squared, is it from the equation?
The field equation. Look. You can say F equals K Q2. F equals E Q2. Because you remember the formula for E is F over Q. And if you have 2 points, the formula for the electric field caused by one of the points is K Q1 over R squared times Q2. So Coulomb's law and the electric field formula is actually really the same thing. This is the formula for E, the electric field caused by a Q1 and the effect it has on a Q2 a distance of R away. But in fact, you look at this and realize it's the same as Coulomb's formula for force. What's next now?
But then there is negative and
Now remember, like I was saying earlier, the purpose of the plus and the minus really is just for direction. Yeah.
then what?
What's wrong with you?
No, when I did that, for one question, I did the question using KQ1 over R squared. And then like, I need to minus it or something?
Huh?
I don't know.
Okay. You tell me when you do know and I can help. Is everybody working on the workbook now? Is that the idea? Yeah? Okay.